So we all know that this summer I Chose Pretty is the worst show that's ever been produced, right? Like we're all in agreement, and we all despise Jeremiah.
Yes.
Okay, good. I'm glad we all agree on that. Good. No objections?
Nope.
Cool. All right. So on this last one, this is the first one that we did. Can somebody give me a really brief rundown of substitution from yesterday? Good. All right. We'll just get into it, and then we'll see if there's issues. So here we go on B. We're going to work a nice one together. And by together, I mean you're going to walk me through it because you're the ones that are going to be doing it. So here we go. We have a lovely system of equations, and we get y equals 3x minus 1. And for our second equation, I'm going to change color so it's easy to see. We get y is negative x plus 3. Could we graph them? Yes, we could graph them. We could take time and do it really carefully, and we'll be able to get a good approximation of the point. But if it's off by a trillionth of a point, I would never know. So there's an issue there, right? So instead, we don't graph it. Can you guys tell me what do we see here that makes substitution clearly going to work? So that's part of it. I think you're right, Kian, but I think I want to change the way that we're thinking about it, because I do agree with you. To use substitution, we want to use it when it's really easy to solve something for one variable. By happenstance, both of those up there have been solved for what?
Y.
They're both solved for y. Are they already solved for y then?
Yeah.
Yeah, that makes it super duper easy. So, step 1, we already have it done. Solve one of the equations for one variable. Would you guys like detailed step-by-step things?
No.
Okay, if you want it, come see me. I'll help you add annotations to stuff. So check it out. We have them solved. All I'm going to do, since I know that this equation has a y, and this one's already solved for y, what could I possibly plug in right here? Cool. What if I want to plug something in here instead? You can go either direction, right? So I'm going to plug the red one in for this y, is what I'm going to do. It doesn't matter which direction we go, but instead of writing y, I'm going to write negative x plus 3. So here we go. Negative x plus 3 replaced this y, and that's still equal to what? 3x minus 1. Just substitute. I'm going to give you 30 seconds. Solve this for x for me.
Oh, I see.
Yep. If you have a value for x, check with your neighbor who probably has a value for x. Don't just shout it out. Let's see if we get the right thing. I'm going to quietly work it here as you guys are going. I was going to say, I didn't get 2. Did I? No, I got 1. Did you guys get 1?
Yeah.
Okay. Are we done? No, but I'm going to put a star next to this. I now have a value of x. What else do I need?
Y value.
Which of these 2 equations should I plug it into?
The red.
What if I said I want to do black?
You can do it too.
Okay, either one is fine, right? Both of them work equally well. Jade suggested the red one. It's a smaller number. I'm okay with that. So here we go. I'm going to use these colors the same. Now I'm just going to choose this equation, completely arbitrary. Either one works. And I'm going to plug in for x. What did we just say x was? So check it out. I've written the same equation, but I left a parenthesis around this x. I'm going to plug in what we just found. It's a 1. Okay, I would strongly encourage the use of these parentheses every time. Negatives, people struggle. Okay, help me out. What's negative 1 plus 3? 2? Okay. I feel pretty good. Am I done? Not quite. There's one thing I have to do. There's 2 things I should do. Before I write my answer as an order pair, there's one more thing I should do. What is it? Before I put my parentheses. So I've already solved it. We have x and we have y. I'm going to check my answer before I commit to writing it. Okay. It should make which of these equations true? Both of them. Now, you can check it by hand. You can check it mentally. You can say you checked it and not really check it and run the risk of getting wrong, like your choice. But let's just try. If I plug in y is 2 and x is 1, let's just see what happens. I get 2 equals, because I'm just plugging in y is 2. 2 equals, what's 3 times 1?
3.
Minus 1.
2.
2 equals 2. Is that true? Yeah, I'm good there. We need to check both. Let's do this one. 2 equals negative 1 plus 3. Is that also true?
Yes.
It works for both of them, right? At this point, I can confidently conclude then that therefore, or I'll use therefore, and we have to write in ordered pair. Full disclosure, I will take points on quizzes, tests, if you don't write in ordered pair when it's supposed to be. Make sure you do it. 1, comma, 2. We're done. Easy, hard,
Easy.
medium. I'm cool with that. All right. I want you guys to do another one. And here's the deal. We're going to make up a problem together. This morning, by pure coincidence, it gave us nice numbers. Are there more nice numbers or ugly numbers? Way more. Way, way more ugly numbers. We might get ugly numbers. I will help you with the calculator stuff if we need. But Declan, give me 2 integers. Whole numbers, positive or negative.
7 and 11.
Okay. Legley, give me 2 more integers.
4 and 2.
All right. I have the sneaking suspicion that this one is going to be kind of ugly. I'm going to make sure that we start it in the same way. And I want you guys to be able to think about stuff, not necessarily exactly like I do, but I want you to consider the same things. Does this problem look a little harder than the previous? It's not really any different. There's something about this that makes me want to do substitution. I'm going to focus on the red one first for instructional purposes. Could I solve this for x? Could I change this red one into x equals something? I'd have to subtract 2y and then divide by 4 is what I see I'd have to do. Now that would give me a 5 over 4. I don't love it. Do you guys want to deal with 5/4?
No.
If we can avoid it, I'd rather not. I could try solving the red one for y instead. I would subtract 4, and then this time I wouldn't get 5/4, but eventually I'd have to divide by 2, and I would get 5 over 2, which is also a fraction. That would work. We could do it. But if you would like to avoid fractions, let's keep looking. This top equation in black, can I solve it for x or for y easily without fractions?
Why?
I can solve that top equation for y. So here's the way that I denote it. You do not have to write stuff down exactly like I do, but I'm very consistent in the way that I write it down. I would solve this equation for y. How do we solve this for y? So we get negative 7x plus 11. Before we move forward, I skipped a line of work. Everybody cool? Okay. Where should I plug it in? This one's unique. I solved the top equation, right? So where do you think I should plug in this value of y? Yeah, check it out. If we solve the top equation here, I'm going to plug in, and you don't have to write this, but it's just really clear, plug in negative 7x plus 11 for y. That's all we're doing. Previous problems, we were given y equals on both of them, and we could just set them equal. This is really what we did, but it's a little uglier. I'm going to get this set up, and then I want you guys to solve it for me. Notice, colors might help. It helps me keep stuff organized. What am I going to put in these parentheses, Duck?
7x plus y.
Almost. What did we say y was equal to?
Negative 7x plus 11.
There it is. I want you guys to solve this for x. And if you want to try to find the end answer, I'm good with it. But for now, I'm just worried, and we're just reviewing the algebra part. Solve this for x. I forgot every algebra skill I've ever learned. Help. Okay, I like that word. Okay, so I'm going to rewrite it. It's all going to be red now, though. I'm not going to take the time to switch. We get 4x plus, what's 2 times negative 7x?
Negative 14x.
Okay,
Oh, wait.
plus
22.
22, still equals? All right, so I think that this is what, negative 10x? Can I do 2 steps in one?
Just flip it.
I'm going to subtract 22 as well. Negative 17?
Yeah.
So x is 17/10, and that doesn't simplify. Okay, notice I have not changed it to 1.7, even though it is. I'm not going to change it. Okay, did anybody get something different for x, or did I make a mistake? Okay, for the record, by the end of the year, it's my hope that everybody can do all this without calculators, but I don't, like, this isn't a calculator-free class. I'm cool with calculators. With that in mind, I want to make sure that you know how to use them. So, what do we do with this x value? I'm not going to touch it yet. We'll get it in just a second. I now have x, so what?
Plug in.
So what's the y value, though? Because I don't have it. And how do I get it? Where would you like me to plug it in? I will. I'm going to plug it into this one, because we've already gone through the work of saying, hey, look, if I know the value of x, you can get a number for y. I'm going to plug it back in here. We know that y is exactly negative 7x, whatever x is, plus 11. I'm going to plug it back in to this one. I could plug it in here, which is the exact same thing. I could plug it in here, but I don't want to. I'm going to plug it into that y equals expression that we wrote at the beginning. So here we go. Y, we're told, is equal to negative 7 times x. And notice, I'm going to leave it blank for a second. What did we just say that x was? So check it out. Wherever there's an x, I'm going to replace it with 17/10. Okay. Again, I want you guys to be able to deal with fractions. In life, you'll probably encounter them again, but I'm aware that you'll always have a calculator in your pocket because cell phones probably aren't going anywhere. With that said, grab your calculators for me. Negative 7 times 17/10. Okay. So here we go. We are going to look at this. I'm going to do negative 7 times, what do we multiply it by? 17/10, and then we add something to it. Plus 11. Okay, I hate decimals. Now, I could change this decimal to a fraction pretty easily. I think you all can.
Where's the slash thing for the fraction?
Just divide.
Oh, okay.
Okay, they're not always going to be just 9/10. If I want to change this to a fraction on my calculator, what do I do? I'm going to hit the math button right here. So I have this number, math. What is, so up here, I'll refer to this later. These are my tabs. We have math, number, computer stuff, and probability. But in math, what does number 1 say? Frac. It's short for fraction. When you're using these calculators, I could hit the number 1 to select that first option, or I can just hit enter once it's highlighted. Like I can tell it's highlighted. I'm going to say frac it. So it's saying, hey, you want me to fraction this? And I say, yeah. I'll hit enter one more time. And there it is.
Oh.
Wouldn't it be something else though? Because aren't you multiplying negative 7 by 1.7?
So check it out. Negative 7 times 1.7. And we're adding 11, right? I think it's negative 0.9.
We're adding 11?
Yep, because notice in our original equation, we had 7x. I can't erase this, so sorry. Every once in a while it glitches. I don't know why.
Okay, yeah, I got
Can't erase, can't undo. So we just got to live with that red stripe for now. Okay, we get negative 9/10, correct?
Yeah.
Okay, this one, there's very few situations where I tell you that I'm even remotely okay with this. Negative 9/10. Do I really truly think that each of you are going to use these numbers, plug it into this to check it? Honestly, not really. But if we have a calculator and you want to ensure that you're right, is it reasonably easy to do? I'm going to do the top one using x is 17/10 and y is 11. So I'm going to type 7 times, I'm going to type in that number 17/10. I lost my spot. Plus y, which was 9/10. So here's this. 7 times 17/10 plus negative 9/10. And it should be 11. That's what my equation said. Was it 11?
Yeah.
It works. I want you guys to check the second one for me real quick. Just verify that it works. Plug in x is 17/10 and y is negative 9/10 right here. And when you do 4 times that plus 2 times that, it should be 5. I'll wait for confirmation. Do you know what I'm asking? I can't tell. Okay, so if you don't know what I'm asking, what do you think I need you guys to do? What? If I ask you a question that you don't even know what to do. Hey, yeah, you're going to ask. Okay,
What did
so
you ask?
yes, I'm asking you to check that it works in the second equation. So in your calculator, check x and y, which means exactly the following. I'm going to plug in what for x into this equation right here. 17 tenths plus 2 times, what do we claim y was?
Oh, it's 10.
Negative 9 tenths. Notice that was just the left side. This is just this, yeah?
Yeah.
When you type this into your calculator, it better be 5. And if it's not, it means we made a mistake. Is it 5? Hey, it worked in the first and the second. Is our answer good? Did it make each equation true?
Yes.
So I'm convinced that this answer is good then. I'm not going to erase with a tiny one. What's our final answer? What's the ordered pair where these things meet?
Negative, 17 tenths, negative 9 tenths.
And we're done. Just to show you guys that this does indeed work. I'm going to go over to Desmos real quick, and I'm going to make you guys read me these equations, okay? Because we just made these up. I won't remember them. Already forgot it. Not a clue. Desi, what's the first equation? Yep. We just did it.
Oh. Y equals negative 7x plus 11.
Okay, I'm going to use this one, but I'm okay with that. I'm going to just type 7x plus y equals 11. 7x, just kidding. 7x plus y equals 11. What's the other one?
4x.
4, oh no, equals 11. Okay, 4x plus 2y is 5. Okay, we just found mathematically, without ever having to graph these ugly numbers, that the intersection should be at 1.7 and negative 0.9, right? Hey,
Whoa.
we got it. Now, Desmos is super powerful. I would encourage you should use it. There's an app that works pretty well also. But I don't want us to have to rely on graphing. And I especially don't want us to have to rely on your calculator's graphing. I think we can do these without ever looking at the graph for now. Cool. Another substitution, we should look at the next method. Okay. Here we go. We've talked about substitution. Do you guys remember from Algebra 1 another method of solving these?
No.
Okay, I'm going to start writing it. You guys are going to be able to finish this. We're still in systems.
Yes.
Ooh, I'm going to use a dash because that's what we used yesterday. Hey, we have elimination. Okay, so here's the deal. I'm not going to throw this around all the time. Whenever I ask a general question to everybody, you now get to pick who you throw that ball at. Here's the rule. We are playing dodgeball rules. We're not playing dodgeball. Don't, like, if I'm throwing the ball to Deck, I'm not here and going, Declan. Nope, not doing that. But at least move a little bit. All right, elimination is what we're after. Nice job, y'all. Okay, for this one, there is a very clear difference in how this works. Now, for the steps, I'm going to give us like 3 really simple steps, and then we're going to work a problem or 2. And I know you've all seen it. It'll come back to you. I'm going to write it a little bit differently than Russell did. I'll write it a little bit differently than Jarvis did. I'll write it a little bit differently than Osmond did if you guys had geometry last year and did elimination. So here we go. When you're solving elimination, first and foremost, nice if solving for a variable is ugly. If solving for one, you can just set it down for now, yeah. Or you can throw it back to me, whatever. For one variable, and I'm going to use VAR because it's what your calculators have as the variable button. Nice if solving for one variable is easy, or is hard, sorry. Okay, we'll see what I mean by this. Now, rather than, I totally switched gears here, rather than saying here's the steps, let's do a problem, we're going to do a problem, and then each of you get to decide. As I annotate and I say here's what we're doing, it's up to you whether you need to write it or not. Okay, so in, I don't know, when I say annotations, what color comes to mind?
Green.
Okay, green is annotations. Here we go. Let's do an example. Okay, example A. Here is our lovely system. We get 2x plus 3y equals 5. And additionally, I'm going to use the same color the whole time. We get 3x minus 4y equals 1. Okay. And yeah, I'll take that back. Someone's going to pick somebody random. One of my most embarrassing moments of my entire life resulted from this, because I had a geometry class that one time was really boring a couple years ago. Just every once in a while lessons are boring. I hope that this isn't just like, oh my gosh, always so boring all the time. Sorry if that's the case. But I was just trying to be lively and obnoxious, so I went and I just, like, I was carrying it around, everybody thought I was going to do something, and I went to it and I just, like, drop kicked it. And then straight into Wisha's face.
Who?
Aisha Williams.
Oh.
So, like, I'm just trying to be obnoxious in the other class, and it's like, come on, and I just booted it, thinking I was just going to hit a tile. Nope, directly into her face. When I can't sleep at night and there's, like, cringy moments of my life running through my head, that is up there near the top, just for the record. All right, so why doesn't elimination work? You could have caught that. I'm appreciate you were looking at the board. We're going to work this out. This is a learning thing. I'll bring a smaller ball tomorrow. Jade, you're holding it. Why is substitution not a great method here? Give it like 30 seconds. If you're going to pop, go. Like, don't pee on my floor or anything. Not sure?
No.
Could we solve this for x, Kian? The top equation.
For x?
Yeah. Like, I could subtract 3y and then divide by 2. And I get ugly fractions, right?
Yeah.
Could I solve the top one for y?
Yeah.
But I subtract 2x and I divide by 3 and I get ugly fractions.
Yeah.
Bummer. Could you solve this for x? The bottom one.
Yeah, but it looks
Ugly fractions. Could you solve it for y?
Yeah.
Ugly fractions. Okay. Substitution would work. If you use substitution, though, you would deal with what? Ugly fractions. Would we rather just not deal with ugly fractions?
Yeah.
Okay. So here's the breakdown for elimination stuff. When we're doing elimination, our goal is to get one of the variables to completely fall out. We're going to change both equations, and then we're going to add them together. Now, you guys have used the draw balance thing before, correct? Okay, for somebody who hasn't, what does draw balance mean?
Putting a balance
It's when you have like something like this, 2x plus 1 equals 3, and when Mr. Russell teaches it, you literally draw like a balance, right? If I add 5 to one side to keep it balanced, I must do what? 5 to the other side. This just helps us keep track. Which means as long as I do something to both sides, I can change the way it looks, but I'm not really changing anything other than the way it looks, right? Okay, so here's the goal that we're after. We can change one or both of these, but we need to get to a point where when we add them together, either the x's fall out or the y's fall out. There's not a right or a wrong. There's oftentimes an easier or a harder approach. Like in this one, what's your gut say? Should we eliminate x or y?
Why?
How come?
Because it's negative.
These are already opposite signs. So I'm in the same logic. Could we eliminate x as well?
Yeah.
Now, if you're not sure about what I'm asking, this is it. Is there a place in your mind that you can find that 2 and 3 both go into?
6.
So I can multiply the top equation by 3 to make it 6x, right? And the bottom one by, I need it to be opposite though.
So divide it by 3.
No, we're never going to do dividing. We're going to multiply to avoid mistakes. I could do it by negative 2. So it would be 6 and negative 6. Okay. I would probably choose to do the y realistically. Do you want to do the x's just because? Okay, let's do the x's. I want these to fall out. Do you want the top one to be positive or negative? Positive. I'm cool with that. And you guys, just to check again, where's the first place, or at least a place that 2 and 3 meet? 6. Here's the very specific notation that I use. Here we go. To make this say a 6x, what would I have to multiply it by? 3. I write it like this. Really, really important. Everything multiplies by 3. The entire left side, the entire right side. So let's just do that. If I multiply everything up top by 3, this 2x becomes a 6x. Plus this one multiplies by 3, it becomes a 9y equals 15. Okay, as long as I do the same to both sides, I'm good. We haven't cheated. I want to add these. And you've probably seen that you can subtract and multiply by fractions and stuff. You can, and it works. I've seen people make mistakes doing it any other way, so I try to just always say, let's add them. Let's take out places to make mistakes. I need x's to fall out. That's what we chose. What do I multiply this so that it becomes negative 6?
Negative 2.
And what gets multiplied by negative 2? Everything. So I get a negative 6x. What's next?
8
Negative.
So positive, because it's negative 4 times negative 2.
Why is it negative?
Because we want these two to be the same number, but one positive, one negative. So we chose negative 2 to make that happen. We'll do another one, and we'll see. It will be a different number every time. Okay. Equals what?
Negative 2.
Good. Everything gets multiplied by negative 2. Okay. Sometimes you will only have to change one equation. Sometimes you have to change them both. Everybody okay here?
Yeah.
Okay, I'm going to draw this, and I don't know its name, but when you add numbers, well, like when you learn to add, this is how you do it. I'm going to add these up. Let's just go straight down. What's negative or 6x plus a negative 6x?
0.
You can just leave it blank. I'm going to write 0x. I'm going to cross it out here in a minute anyway. What's 9y plus 8y?
17.
So 17y. And 15 plus negative 2?
13.
13. This term doesn't really exist. It's 0. I don't need it. I just want to make sure that it's clear that's what happened. Can we solve this for y? Okay. What is it?
Divide 13.
Divide both sides by what?
13.
Try again.
17.
17. Okay, this is awful. And those of you that claim you like decimals, we can switch it, but real quick, what's 1317 as a decimal? Nope. Okay, so it's not that you like decimals, it's that you like your calculator. All right, I'm going to put a star. That was kind of snarky, but it was intentional. So sorry if I hurt your feelings. Am I done?
Sure.
Almost. We're close. I need an x, right? Now, luckily for me, I have a bunch of equations up here that are all work. I can pick whichever one of these I want to plug y into. I would recommend, I don't know, which one?
Top.
Sure. Could we have done the bottom of? Any of them will work. You could use these, but these are just bigger versions of this. I would never use the right side. So let's do the top one. I'm fine with that. 2x plus 3, gosh dang it, what did we just say y was?
13.
So obnoxious change of color. And I'm plugging into the top one here. Still equal to what? 5. I have no issue if you use your calculators. I can show you how I would use my calculator. Solve this equation. Calculator, hand, don't care. I just need a value for x. I'm going to do it by hand while you guys are doing it on the calculator.
5.57.
Yep, math racket.
I don't remember that.
Nope, it's okay. I'm going to help you. Do you still have your answer? Okay, hit math. And 1. Or answer. And one more time. Oh, there it is. I bet I get the same thing. So looking at this, let's see, that's 85 equals 85/17 minus 39. I'm doing this without a calculator. And 85 minus 39 is 36? Is that right?
39.
You get 39?
Yeah.
Where'd you get the
For which part?
Over 7.
I'm not going to use my
39
calculator.
Over 7, not 17.
Over 7? Did you type in 7 or 17th? We'll get there. We'll see if we agree. Everybody okay with what I've done? I don't care if you can do the fraction stuff. That's not our focus. What's 85 minus 39? That I'll use a calculator for. 46? That feels right. Okay, so I think 2x on mine, check it out, I'm doing it without a calculator, is this. And then I'll divide by 2, but that's the same as multiplying by what? 1/2. So they're gone. 1/2. I think I get 23/17. Did your calculator give you 23/17? So I got one confirmation. Anybody else? 23/17 is what I think it is.
Why?
I'm doing mine by hand, and I might have made a mistake.
The cross up makes sense.
Because instead of doing 2 times 17, I'll just divide them out here and simplify before I multiply. Okay. I need confirmation from your calculators. And I will actually also get confirmation in the calculator, but I'm going to make it so that I can see both of them simultaneously here. All right. So we're trying to do 2x. I think it's going to be 23/17, but we're going to check. I'm going to, I can't do this. Okay, if this is where we start, just kidding. Here's where we start. Do you agree the first thing you're going to do is that multiplication? Okay, 3 times 13/17. So here we go. 3 times 13/17. It gives me an answer. Now, I'm going to subtract that from 5. Everybody agree with that? I'll subtract it from both sides. So I'll do 5 minus, and I'll just scroll up on here to get that number. I have one more step. I have to divide it by something in the end. So here's what I've done, and I'll clear all this. And I'm trying to mix and match, like showing work and using our calculators, which is a weird thing to do, but I care more about your math. This is the first thing that I just typed in. 5 minus 3 times 13/17. And I got this ugly number. What's the last thing you would do? So I'll even write it here. 2x is 2.7 gross. Hate it. ... Who cares? How do you solve for x? That's what I need to hear. Check it out. Divide by 2. Yuck. That's awful. If only there were some math to make it a fraction. Oh. Math. Frac? 23/17?
Yep.
Is that what I had?
Yeah.
Oh, thank goodness. I lost it. Okay, so if you have to use a calculator, I'm totally fine with that. 23/17. Okay. Same thing is going to happen here. I'm going to use Desmos instead of making us plug it into our calculator. I claim that it's 23/17 and 13/17. 2x plus 3y equals 5. 2x plus 3y equals 5. What was the other equation? No, too many people at once. Go about 3 times louder. I'm old.
Oh, the first one?
Sure.
2x plus 3y equals 5.
Okay, and the other one?
3x minus 4y equals 1.
Okay, we just claimed some terrible numbers. Let's see, 23/17. That should be approximately 1.35. Hey, we're right. Now, again, I really want to stress, I don't care if Desmos can do your problems. That's not my job, right? It's not to teach you how to use Desmos. My job is to teach you the math, the mathematics underlying this. If I said no calculators allowed, 1, I'd make sure the numbers were nicer. But 2, would it be easier to solve by graphing or just by using one of these methods? You think you'd rather graph by hand and you would get 1.35294?
Graphing with Desmos.
Graphing with Desmos is always going to be the easiest. Graphing by hand or solving it like this is preferred. Solving it. You're going to get an answer compared. Okay, should we find a nice one that works with elimination? Do we need another example with elimination? Good? Bad? Sad? Happy? Jealous of how cool I am? Oh, earthquake because of all that eye roll. Okay, so one more real quickly. And I might just give you homework instead. Cool. All right, let me find an assignment that's not huge. Your book goes so much further than this in one lesson, and I don't think that it's an appropriate amount to try to push forward. I have an algebra book. You have, somebody has a book somewhere. I have one. Where's mine? I'm trying real hard to give you guys homework. Here's a book here. You guys. All right, 1.6. Tomorrow, do you guys want to try to, do you guys know what it means to inflect your voice? Like to change the tone? Tomorrow, let's make an agreement and see if anybody remembers. I'll remember. We're going to end every single statement that we have tomorrow with an inflection upward at the end. Now, there's some fun consequences of this. We're going to start it right now. Tonight, you guys are going to have homework. That was a statement. Okay. So for tonight, I think that I want you guys to work a few problems. We'll call this homework 1.6. And you will find homework 1.6 on page 51. All right, I'm tired of that already. You guys get 4 systems of equations. Okay, this actually starts on page 50, but you'll see it. You guys get number 5, 15, 16, 17, and 18. In hindsight, I should have just said 15 through 18, but here we are. 5 and 15 through 18. Okay, here's the deal. Do I care if you check with Desmos or a calculator? No, but if all you have on your page is an answer, I'm going to give you 0 credit for it. I need to see that you're solving systems of equations using the algebra. You can check with the computer or don't, like that's your choice, but I want to actually see your math. Cool. If you're going to take the time to fake doing the math, you might as well just actually do it. I think it'll be faster to do that, in all honesty. Cool. I don't specify, nor do the directions, whether you should use elimination or substitution. The choice is yours. They will both work all the time. I would try to choose which one's easier. And then tomorrow, you'll see the very next problem in here. We get these types of systems. Big uns. And some inequalities, but we'll deal with it. All right, cool. We have like a minute to debrief. Do me a favor. I don't think anybody's going to start their homework. Jade, you proved me wrong. Sorry. On your bell ringers, there's something today that probably didn't sit super well, you struggled with, or was hard, something. I want you to leave that comment on your bell ringer. So you have your triangle. What's up?
We did the bowling, right?
Yep. And all I need is, what did you struggle with today? What did you find challenging? Something that can help me know what we need to focus on moving forward. If everything went well, I'm okay if that's what you say, but you can't write it every single day because everybody will struggle somewhere. The folders, on your way out, I am totally cool if you just stack them on the desk as long as they're all in the same orientation. I will put them in the file cabinet.
Put the bell ringer in the folder.
Yep, the bell ringers go in the folder. Cool.